Just to introduce myself quick here, I am Brian Walker, and I'll show a picture here quick. That's me. I have about 10 years of experience with TerraSource and previously Pennsylvania Crusher. Now, our presentation today is on granulators. Granulators are a very interesting product for us. It's a very old product. We have about probably around 1,800 to 2,000 granulators in installation or in service throughout the world. But what is a granulator? It's a one-way hammer mill. It has ring hammers. It's operated generally at slow speed of 3,000 to 9,000 feet per minute, or 15 to 45 meters per second. Typical reduction ratio is 10 to 1. Granulators are typically used to reduce friable material. 95% or more of them are used to reduce coal. Input size is usually 6 inches or less. It could be more. It could go up to 12 inches in some applications. Our heavier duty models can go even 18 inches of input size. And the typical output size is ½ inch or 12 millimeter up to even 2 inch. Usual applications are in power plants. For instance, PC boilers, pulverized coal boilers. These are the primary crushers at a power plant, usually preparing the fuel for the pulverizer, reducing the fuel from the train or the barge to prepare it for the pulverizer, and then from the pulverizer the coal gets blown into the boiler. Can also be used to reduce the coal prior to storage. An advantage is this type of machine gives minimum fines production, therefore less coal would be blown around on the coal pile. Other applications would be a fluid bed boiler, in which case the granulator would be the final sizer before the boiler. It's a different type of boiler than the pulverized coal boiler. So product size from the granulator is a lot more critical with fluid bed boiler application. Yet another application would be a coal preparation plant. Granulator could be used for crushing raw coal or even as a clean coal crusher to further allow processing of separation of the rock from the coal. Now, referring back to Jack Loeb's original webinar, Crushing 101, we will look at the reduction methods that granulators use. Primary reduction is done through impact. As you can see with the arrow at the top, the hammer comes around, impacts the coal, and then the hammer then rolls across the bed of coal and further crushes through rolling compression. General operation of a granulator is, as the rotor rotates, you can see on the slide, the rotor rotates counterclockwise. The material slides down the breaker plate. Then the hammers encounter the material or impact the material. The hammers are held out by centrifugal force. Therefore, the impact impacting the feed and making the initial breakage. And then the hammers begin to rotate on the bar. As I mentioned before, you get rolling compression and reduction, further reduction. The material is sized as it passes through the openings. All the material must exit through the screen plate, which means if there is a piece of uncrushable material in the feed, such as iron, then it will not exit through the screen plate if it is larger than the opening of the screen plate, in which case we allow the material, the uncrushable material, to be caught in the tramp iron pocket. Now this tramp iron pocket fills with coal fines. The coal fines actually absorb all of the energy that this piece of tramp iron would have. The tramp iron actually acts as a projectile, and the coal fines that fill up in the tramp iron pocket absorb that energy from that projectile. Here I got a little ahead of myself, but the uncrushable strike the deflector plate and become embedded in the tramp iron pocket. And periodically, the tramp iron pocket needs to be emptied through the clean out door, which is on the right side of the picture. Now this tramp iron pocket typically is emptied once a day. It could be emptied once a week. It really is dependent upon the plant's operating procedures and the plant's experience of how much tramp iron they receive. Operation is controlled by, the output size is controlled by screen plate openings. The openings vary with the type of coal and the product size required. Rotor speed also impacts the sizing, and the cage setting also impacts the sizing. So with a granulator, there are 3 methods of product size control: screen plate openings, rotor speed, and cage setting. Now, to adjust the cage is adjusted to compensate for wear of the crushing elements. It provides a little bit of variability in the product size. Generally, the way that all of our crushers, our hammer-type crushers, are adjusted is by not feeding coal. You run the crusher. So the crusher is run empty, and then the cage is adjusted up to the point at which the cage starts to click the hammers. And then from there, the cage is backed off. The amount that is backed off depends on the plant's experience. So it could be backed off 2 turns to get the correct product size at one plant, or at another plant they may determine 20 turns is the correct amount to back it off. Now, the types of granulators that we produce are the TKK, which we will be discussing further on in this webinar. We also produce the TK. That is a machine that is designed for heavier feed, larger feed sizes, also for, say, primary crushing applications. And very rarely we produce the JRK, which is a very small, almost a lab-size crusher. Our model designation, as you can see at the bottom, is TKK, and then the diameter of the rotor with the hammers extended, and the width of the screen plate designated in inches. For instance, a TKK 26 by 30 is a 26-inch diameter rotor and 30 inches wide. Now, within the TKK, there are 3 designs. The largest design is the 44-inch and larger, so that could be a 44-inch rotor diameter, 48-inch rotor diameter, 60-inch rotor diameter, or even 72-inch rotor diameter. This design has 4 rows of hammers, typically a staggered pattern, which means the first row has a space between the 2 hammers, and then the second row fills in that space as the rotor rotates. So it's a staggered arrangement. And the hammers are typically 45 pounds Although on the rear quadrant is hinged, and you'll see a picture of that. And we also have rear adjustment, or adjustment from outside. The 36-inch diameter design has 3 rows of hammers, in-line arrangement, so it is not a staggered pattern. The gap between the hammers on the first row of hammers is not filled in by the second row of hammers. This is impossible since there's only 3 rows of hammers. Typically 27-pound hammers we have in the 36-inch diameter rotor, and we have a rear quadrant which is hinged. On the 26-inch diameter, we have 2 rows of hammers. It's again an inline arrangement, 27-pound hammers, and no hinged rear quadrant. But because it's so light, we can remove the top cover by hand. And you'll see more pictures of each one of these designs. For instance, here is the 26-inch Coal King, and I'll point out the feed comes in from this angle, enters the hammer circle, slides down the breaker plate, which is inside the crusher. Rotor rotates in this direction. Tramp iron pocket is over here. Here is the cover for the rear quadrant, or the tramp iron pocket. Removing this cover, you'll be able to see the hammers and replace the hammers as needed. So further on, you'll see the fabricated steel shapes. Basically, it's a pretty simple design. The frame is made of fabrication, welded steel plate. We have carbon manganese plate liners and covers over the access panel, as I mentioned before. The rear quadrant cover here, and this is the cover for the tramp iron pocket. Now the 36-inch granulator obviously is a larger machine. With this machine, you can see, again, this is the rear quadrant. So this rear quadrant actually is hinged at this point here. So the quadrant will actually open up. So someone could actually stand inside here with this rear quadrant open and work on the hammers, replace the hammers. Also shown here is the tramp iron pocket doors. So these doors can be opened on a daily basis. Again, the frame of the TKK, of all of our TKKs, are fabricated steel shapes, welded together. Carbon manganese plate liners, hinged rear quadrant. You can see here a picture of the rear quadrant actually open. You can see at the bottom the hinge portion of the rear quadrant. You can also see there is very good access for the client to get to the rotor and lift the rotor up and out of the way as needed. The rotor doesn't always need to be lifted out of the way to replace the hammers or even to replace the screen plate, which I'll discuss further. Again, looking at the largest design of our TKK model, we have a frame, again, fabricated steel shapes, carbon manganese plate liners, hinged rear quadrant for rotor access and rotor removal. And on this model, we have an optional hydraulic door opener, which you can see right here. We have a hydraulic piston. This is a nice option for customers that are concerned about safety. Very simple operation. Previously, the customer would have to open the rear quadrant by suspending cables or chain from above. And then what would happen is the customer would pull the chain, have a chain coming from one direction to open it, Once the center of gravity passes the hinge point, they would have to have a second chain from the other direction to keep it from falling down. So having the hydraulic door opener is a nice feature. Looking inside the TKK, all of our TKKs, we have breaker plate, which is a solid breaker plate. We have screen plate thereafter. Our screen plate are slotted screen plate, and the opening could be for a 75 millimeter, for a 3/4 inch product size, you may have, say, 2-inch opening. The reason for the large opening is the angle at which the screen plate sees the material. Removing the front door of the granulator, you can see the back of the breaker plate and the cage frame. You'll also see the pivot point at the top. So to remove the cage frame, if you would ever have to do that, the saddles of the cage frame can be unbolted and then pull the cage frame directly out of the page. On our larger units, you'll see a center support, and that is obviously necessary as the breaker plate gets wider. So on our smaller units, you'll see we have adjustment for the breaker plate from the outside. This is a picture of the 26-inch granulator. So it's a very simple hand adjustment. There's an adjustment mechanism on both sides. Here you see only one. On the 36-inch and larger, we have adjustment again from the outside, but a single point adjustment. Here is a picture of actually a 44 or 48-inch TKK granulator, and it actually has what we call synchronous cage adjustment, which is 2 gear jacks and then a ratchet device linked between the two. Therefore, only one point of adjustment on the largest units. Again, this gives you a picture of what I was discussing earlier about the removal of the cage. The cage can be removed by removing the door, the front door, and then pull the cage out from that side. This can be done without disturbing the rotor if need be. Here's a picture of a rotor. This happens to be a 26-inch rotor. You can see what I was discussing earlier about the tracking pattern, or the non-staggered pattern, or inline pattern. The first row of hammers is followed by the second row of hammers, and there is a gap in between the two hammers. These hammers are held on by the suspension arms, and the suspension bars are held by the suspension arms or suspension discs. In between the suspension discs, we have spacing discs, and at the end of the stack, of the rotor stack, we have a disc clamp nut and a sleeve to compress the stack together. And then, of course, we have bearings on either side of the rotor shaft, and the drive connection, keyed drive connection. On the 26-inch granulator, you can see you remove the top cover and then the side plates, and you can easily remove the rotor from the cage frame. And the feed chute above does not need to be removed, which is a feature that a lot of our customers really appreciate. Saves them a lot of work. So on the 36-inch and larger, rotor removal is done by opening the rear quadrant, and then you can see you slide the rotor to one side, and then you lift the rotor out. Again, the feed chute does not need to be removed. Looking further into our bearings, they are self-aligning spherical roller bearings with a tapered bore. They're split cast iron housings with labyrinth seal, and the lubrication is done by grease, which is our standard, although we do frequently do, or infrequently, we do oil as required by the customer. Here you can see what the tapered bore looks like on the bearing race and the shaft. This, we use a tapered bore, which will allow us to also pre-drill the bearing, the shaft for hydraulic removal of the bearing. So connect oil pressure here, and it pumps oil into the inside of the bearing race, and that pressure from that oil actually expands the inner bearing race and allows the bearing to be easily removed. Our ring hammers are forged alloy steel, heat treated to 300 or 350 Brinell hardness. Generally we have teeth on our hammers. The teeth allow the hammer to rotate along the bed of material, again to help promote crushing, the rolling crushing effect. So feeding requirements for a granulator are slightly different than a center-fed machine. If you tuned in on the impactor presentation or the hammer mill presentation, we want the feed to drop from a zero vertical velocity or zero horizontal velocity. With a granulator, we want the material to slide down the breaker plate or slide down the feed chute into the crushing chamber. And typically we like to see 20 degrees on that angle. And for 48 to 84 inches of drop height to allow for enough speed for the material to enter the hammer circle. We also want to see even feed all the way across the width of the rotor. So essentially each hammer does the same amount of work. The reason for this is for even wear. As the hammers wear, the breaker plate is adjusted in to compensate for hammer wear. Another reason we want to do that is if the hammer is, or if the crusher is only fed from 50% of the width, you can expect roughly 50% of the capacity from the crusher, which obviously customers want to get 100% of the capacity. Therefore, we recommend 100% even width. Again, illustrating our sliding requirements of the feeder, of the material to slide down the feed chute and penetrate the hammer circle. So, with that, are there any unanswered questions about granulators or about feeding granulators? Well, if there's no questions, I think I will end it right here. And I appreciate everyone's time. And if you do have questions, feel free to contact your sales representative or your regional manager for TerraSource, and we would be happy to help you. Thank you.